the focus of today is to take a look at API load testing. We're going to try and do it in a very abbreviated manner, and I want to, preface the presentation by saying that there's going to be a lot more depth to the tool that we're looking at today. We're really only going to skim the surface and introduce a lot of the functionality and why we see teams really engaging with it, especially when they're coming from a tool like SoapUI. There's a lot of reusability, which we can see, and it's a very expedited process in standing up one of these performance tests as compared to something like a much larger suite or set of tools or something that's cloud-based. So before we dive too far into this, anybody who's not familiar with SmartBear, we've been around for a number of years. We have a very large user base, about 6.5 million users, and this is across both the professional tools that we offer, so things like SoapUI Pro, LoadUI, Wright API, Swagger Hub, but it also ties into our open source offerings. So anyone familiar with the SoapUI open source versions that are out there? We've got Swagger, which is a whole suite of tools, essentially a development platform and standard for RESTful APIs. All of those we develop, we build, we maintain in-house, and they are part of what we consider to be our active user base. We have a worldwide presence here, so global offices, we've got a number of users, or a huge amount of users in locations all around the world. So just something to keep in mind, when you're communicating with us, when you're looking for support, when you're trying to get access to something, we have local versions, we have different languages, we have different support staff in different areas. So a lot of ways that we can really engage with you and make sure that you get the best support possible. It's not just a single office tucked away somewhere. Really, big piece of what we do is have that global footprint. So today we've got a very strict agenda. We're going to do some very kind of pointed things with the tool, and as I mentioned before, I want to make sure this is just kind of surface level digging into LoadUI. So the first thing that we're going to do, we're going to take a SoapUI script. We'll talk a little bit about what it does. We'll explore using SOAP, REST, and finally a data-driven loop setup, and how we can move that over into the load test environment. Essentially, how we can bring them all into a single performance test and start to do things like gather metrics against two different services, maybe a SOAP and a REST service that replicates some kind of functionality, and we want to make sure that both users experience similar load times. So we'll make that transition, we'll then configure it, we'll talk a little bit about setting up the scripts and kind of setting up the load tests. We'll take a look at some of the metrics that we're gathering. Again, we pull things in at a very high level, but we'll dig into some of the ways that we can get specifics out of the tool. We'll talk a little bit about distribution, how we can say run this from not just a single machine, my little laptop, but we can distribute to multiple different machines. We could even stand something up on a cloud instance, a server in the cloud. Really powerful piece of what we do. Finally, we'll kind of wrap things up talking about reporting, how we get all of this information, all these metrics, all this data, and how we could feed it into some different platforms, how we can make it readable for everybody who's getting the email after something is run. That's the goal of what happens after the execution. And then finally, we're going to do a little bit of a talk on scheduling and automating the process. So how do we tie in this load test to something like Jenkins so we don't have some poor soul who's standing there at midnight waiting to run a load test on a Saturday when we could just have a process or batch script that's going to do that for us. All right, so let's go ahead and dive right into the tool here. Just minimize this down. And as I mentioned, the first thing that we're going to do is talk a little bit about SoapUI. Now, this is the easiest way to get started with a load testing tool. It's not the only way. You could definitely come in from scratch and start to build out some requests and chain some steps together. But for the purpose of the demonstration, I think that this is the most effective and the easiest way for us to get started. Now on the left-hand side, as I mentioned, we see that we have a number of different test cases. We've got a little SOAP script. When we open this up, we see that it's a very basic sequence of steps. We log in with a specific value, search, buy, log out. Always looks the same. So these are hard-coded values. It's going to be the same every time I run it. And this is something that I designed. This is something that I intended when I built this, this test case out. As I mentioned, maybe we've got this use case where we're migrating over to, some kind of microservice system or some kind of RESTful version of the SOAP service, this legacy system. And we've got that same sequence of steps, but the way that it returns is a little bit different. So we're getting tokens back. We have to pass that in subsequent calls. There's this element of authentication, and it works. And the idea here in Wright API and SoapUI is to test that functionality, but we also want to make sure that that carries over into LoadUI. And we'll see that when we bring things over, it does just that. The final element down at the bottom is how we can start to test some variability. So let's say that we wanted to throw in some bad logins. Maybe we wanted to try and break the API and throw in some, strange characters and that kind of thing, some edge cases. All of that we can start to think about putting in something like our data-driven setup. And so instead of just the same values over and over and over again, we can actually create this iterative loop that we're going through, and we check all of those edge cases and those different inputs. This is something that I think translates really, really well to the performance testing space. When we're running this at scale, we don't want to just send the same request X number of times per second. If we've designed the API and if the server is built in the right way, it's going to start caching those responses. It's going to do a really good job of handling that, same request again and again. So for us to be able to provide some variability and for us to be able to build on top of that variability, I think is really, really powerful. And one of the huge benefits when we look at moving from something like SoapUI into that performance testing tool. So enough talking about it, let's go ahead and do it. We minimize down these test cases here, and we'll find that through a right click, I can generate a load test. Now, this is gonna move us right over into LoadUI. Let's try and give it a different name. Here we go. This is going to bring us right over into LoadUI, and we can see that that test case has been put inside something called a scenario. Now, these are essentially the building blocks of what we do within LoadUI. When we talk about distribution, when we talk about metrics, when we talk about the way that we configure the virtual users, all of this breaks down to that scenario level. One of the nice things here, we can build multiple scenarios. You might say, Nathan, what's the point of running the same test case twice? Well, we can very easily change this as well. So we find that we have access to those test cases that we were looking at before, as well as some of these from other projects. And as I mentioned, this isn't the only way. So we can definitely pull in individual requests or just copy paste the URL to run our requests against. Let's go ahead and pick that RESTful test case. We open this up, we can see all of those same steps have been brought down. And then finally here, let's go ahead and bring in that data-driven loop. Now, there is one thing that we have to verify. Most of the time with any version of the tool past, I think 2.2, this is done automatically, but we can see that the data-driven setup is pulled right in here. When we jump back into SoapUI, we can open up this step, and we'll just want to verify that it's configured in the right way. So let's make sure, load testing, there we go. So yeah, just two little settings that change the way this runs when it's in the performance environment, just something to keep in the back of the mind as you might work on these. Great, so now that we've imported all of these, we can go ahead and start to run our test. Full disclosure, these are running against a virtualized API that's on my local machine. So we're not actually reaching out and touching any kind of deployed API. It's all happening internally. But for the purpose of the demo, we can see we're starting to get some metrics back on the right-hand side. There's a couple of lines being displayed. One is going to be our failure rate. It's set at 0 right now, so everything's looking pretty good functionally. The yellow line is going to be our aggregated response times, and it's very high-level data at this point. It's not really giving us any kind of exposure to the different scenarios, the different requests within each of those scenarios, and that's exactly where we want to start to dig into some metrics, and we'll do that in just a second. Before we do, I want to talk a little bit about this blue line that's right across at the top. This represents the number of concurrent users or simulated calls that we're currently sending, and it's 15. And from the time that the test starts to the time that this finishes, we can see that that's a fixed value. This is useful for something like a smoke test, or in this case, if we're treating this as like a performance sandbox where we're just trying to simulate some calls. That might be okay, but let's say that we had a crash or something, or we had some kind of performance issue that happened when we had a certain user flow. Maybe it's across multiple scenarios, maybe it's across multiple services. That's exactly the kind of thing that we want to be able to recreate and that we want to be able to simulate so that the next time that it happens, the service and the APIs are designed and robust enough that they'll be able to handle it. The tool has a lot of ways that we can change our simulations. Right up at the scenario level, we see that we have this little setting called a load profile. Now, when we change this from fixed to something like a ramp up, this is going to right away tick this over into more of a stress test environment. We could just continue to add new virtual users until we break some kind of assertion or trigger or something that we have within the tool. Very, very useful. Ramp sequence, I see this used an awful lot for distributed load testing. So let's think if we have, a bunch of different machines, we've got some cloud services that are all going to be simulating requests. Instead of us just starting to run those all at once, we can essentially start this kind of build-up process where we can kind of iterate over the virtual user counts and build up to that high level value over the course of a few seconds or minutes. Essentially give us a little bit of runway to get started. Hopefully, eliminate any kind of edge cases as things essentially boot up. Last one down at the bottom here I think is quite interesting, custom. This is gonna give us a menu that lets us draw out a custom graph. So if we have exposure to that analytics platform, we can pinpoint what kind of sequence happened that caused a failure. It's very easy for us to now replicate that within this editor. We would find that when we run this test, the virtual user account is gonna map to this graph. And as we see, it's very, very easy for us to configure this really in any kind of sequence that we want. And I think one of the nice things here is that each of these load profiles is actually assigned to the individual scenarios. So we have a lot of flexibility here when we start to dig into this in a little more detail. All right. So we've talked a little bit about configuring this, talked a little bit about the virtual user account. The only other thing that I'd mention here is the ability to change the way that we simulate this. So some of those out there might have seen or might have noticed that this value isn't really changing. It's not ticking up or down the way that we might expect if we were simulating, in this case, 5 per second across each scenario. That's because we have something called a virtual user type. What this is doing is essentially waiting for a set of responses to come back from the API before it initiates a new sequence of calls. What that means is that there's never more than X number of requests being served by the server at any one time. This is something that we can definitely change. So if we wanted to bring this more in line with some other tools out there, we can set it to what we call a Wright, and it would just set X per second for the duration of the test. We could be getting nothing back from the server. It could be on fire. It could be, all going terribly, but we're just going to continue to simulate those requests without really any concern for what's coming back. So definitely some flexibility there as well. So I think we've done a pretty good job just introducing some of the configuration options here, hopefully giving people enough to get the feet wet with setting up these tests. What I want to dig into now is how we actually start to gather some metrics here. As I mentioned, this yellow line it's nice, but it's not really giving us any depth. I have no idea, SOAP, REST, which of these is causing these upticks that we see right at the top of this, this graph. To do that, we're going to pull up our statistics tab. Now, this is where we create custom graphs and tables with exactly the data that we want to show and include in our reports. This could be something very high level, failure rates, failure kind of frequency across the entire test. When we open this up, we see we get scenario level metrics, but we can get even deeper down to the individual request level. So let's say that we had a login step for our SOAP and our REST calls. We can actually compare both of those against one another directly. Get a really good idea of, potentially as things scale up, do we see any kind of slowdown? Are they kind of close enough that we consider them to be in a certain tolerance of each other when we were defining an SLA? There's a lot of reasons that we want to do something like this, and I guess the real point here is that we have a ton of flexibility with the data that we're collecting and what we're displaying. So it's not like we're just dumping it out into some kind of pre-conditioned or pre-canned report. We give you the option to say, this is what I want to see, this is who I want to share it with. And then it's just a matter of setting it up. All right. So a lot more detail that we won't dig too far into here. We can create tables as well. So instead of this kind of graphical view, we can get a data table. We also pull in historical data. So comparing runs from say a week or a month ago, potentially we made some changes, bumped up the hardware on the server. We want to see what impact that has potentially had. We can actually take 2 sets of data and overlay them. So a lot of flexibility there with how we pull in historical values. Something else that I want to mention here, and is kind of in line with what we've just been talking about with these statistics, it's the monitoring capabilities within the tool. I think this is a little unique from what I've seen in some other platforms. Essentially, we can create one of these server monitors through a permissions-based system. So there's no agent, there's nothing that I'm going to run on another machine. Essentially, all I have to do is pick the type of machine we want to kind of pull values from. It's going to pull the performance monitor data from that machine, and it's just going to serve it up into the API behind LoadUI. So now we can see that we have down at the bottom, let's just start this to run, memory, processor usage data. That's going to be graphed out right on the bottom here. I could configure this graph to show me network or disk kind of read-write times, whatever it might be that I think is going to be useful and I want to render out. I can customize right on this graph. But I think the real value comes in here when we start to look at this against things like response times and failure rates. Now we have access to that server monitor. We can dig down here, take a look at maybe our processor usage. might give us a really good indication of if there's any kind of correlation between what's going on the machine, on the hardware itself, and with our response times that are coming back. And again, a lot of flexibility there with the data that we're collecting. Great. So I talked a little bit about metrics here. Again, oh, finally showed up there. I was hoping that would happen. That gray line represents our CPU usage, just something to see there. We talked a little bit about configuring this, setting this up. We talked a little bit about metrics, gathering this, the server monitor component. One of the key things that I want to focus on here in the last, let's say, 5 minutes of the presentation is the distribution model. I think this is something that really separates us from a lot of tools that are out there. It's something that I see a lot of people really engage with, and one of the most used features. I think, you know, it tells itself when people are using it, it tells its own story. Now, right now, everything's coming from my local machine. We know that all of my requests are localized, that coming from my individual laptop, which is streaming this and also running, as I mentioned, the API as well, the simulated API. How do we scale that up? That sounds like a recipe of a disaster if I go over anything like 10 or 15 concurrent calls. One option would be to build out a dedicated machine to stand up some kind of LoadUI instance on it, start to, you know, have it robust enough to simulate potentially thousands of concurrent calls. Another option, what we see teams do, is start to use this distribution model. What we can do is download something called an agent. It's a very lightweight program that can be set to run on really any machine, Mac, Linux, Windows, whatever it might be. It could run in the cloud or on something like a Raspberry Pi. Once that's up and running and it's in a network that we can connect to, we can go ahead, reach out, connect to that agent machine, any number of these actually, and we're going to be able to take any of these local scenarios that we defined and distribute them in any combination to these agents. So this could be a combination of really powerful machines, maybe a cloud server that has a ton of resources. I could sling all of my scenarios onto it. Maybe I've got some very lightweight machines that I want to use. I could put individual ones on there. There's a ton of flexibility with how we use this. And there's no licensing model. There's no cap on this. There's no limit to the number of these agents that you can have up and running in your own network. It's really just how many concurrent calls across all of them do you want to simulate? That's how we start to define and how we start to scale out the licenses for LoadUI. We can see it right up at the top. So for instance, with 2 agents, I could have 125, and that's being actively simulated. So per second, how many am I currently making these calls to, not total. So again, something very flexible there and a really powerful piece of what we do. I should mention, we do have a direct integration with Amazon EC2. So if you are using the Amazon Cloud Services, really straightforward process to reach out, connect to one of their data centers, start to simulate requests and say compare traffic from across the world where we have no offices to something that's happening at the desk next door. So again, just a lot of flexibility with how we start to distribute this. Great, so I know that we're coming up to that 20-minute mark. I think we started, 1:03, so I wanna make sure we tie this all up with a couple of what I consider key features for actually executing these. We'll talk a little bit about reporting before we do this, but then we'll look at how we automate this and how we schedule it from the time that it does start. So right up at the top is a reporting button. If you're familiar with SoapUI, it's gonna look pretty similar. We've got some flexibility in the ways that we export data. Data export would be like an XML or a CSV file. Load test report is kind of what it sounds like. It's high-level data about what happened over the course of that load test. And it's gonna be put into a PDF style file. So it's gonna let me know, you know, pass failure rates for the entire test. Here it is. A little bit of kind of a breakdown of what the test was, how long it ran, etc. But then at the end of the document, we'll see that we actually get all of the custom graphs and tables that we took the time to create appended on. So a lot of ways that we could potentially customize this and build this out a little bit further than the templated version that we have if we've taken the time to do a little bit of work in that statistics tab. All right. Automated runs, this is very similar to what we support with SoapUI. So when we right click on one of these load tests, we see that we have access to something called the LoadUI test runner. This is a very small utility that lives in the installation directory of Ready API. Essentially, it's a way for us to pass commands against it. It's going to execute a load test and generate reports or data after it's executed. But this is just a nice way for us to configure those command line arguments without actually, going through the documentation manually, kind of building those out. Things like the different environments that we want this to execute against, things like the reports where they should be stored, any kind of data groups that we want to export. And again, this is going to be defined in that statistics tab. Let's say that we wanted to write a bunch of information to a CSV file. This is the field that we'd be able to do that in. But we'll find that when we hit launch, the tool is giving us this little script right across the top. This is exactly what I'm going to be able to use to now invoke this from outside of Ready API. Just copy paste that, make sure I'm doing it from within the bin folder of the current installation version, and it will essentially run in a headless environment, generate all those same reports, but with very little engagement from me. I do have a instance of Jenkins running that we should be able to take a look at this in. Let's just very quickly here switch over to that screen. Great. And this will probably be one of the, probably the last thing that we'll take a quick look at here is just how we tie this into a platform like Jenkins. Any questions that you might have, feel free to post them, as I mentioned, into the chat box, into the, oops, there we go. So is this session being recorded? Absolutely. So we'll send out a recording to everybody who attended, and there's been some great people joining from all around the world. Really good numbers here, which is great to see. So yes, everyone will get a copy or a link to the recording, I should say. We're not going to send you a copy of the file. A link to somewhere where it's going to be hosted. And then anyone who was unable to join, if you have colleagues, coworkers, you want to share this around, we're going to host this as well on our website. So plenty of ways that we can access this recording after the session here. I do see the other question. I'll get to that in just one second. I do just want to point out how easy this is to run. We can see here on my left-hand side, I've got all of these previous executions, and it looks like I'm having a nightmare of a time running some aspect of my load tests. But we could go in, we could take a look at the configuration. It's very straightforward the way that I set this up. It's essentially a copy-paste of the script that was given to us by LoadUI. You can see that that's executing in my install directory. Down at the bottom here, we're picking up XML type files. So these are JNet style HTML reports that the tool is spitting out. Now, if we had any successful executions, this would mean that we could go in to any of those previous runs, take a look at the data that's been reported. In the terms of these failed tests, I actually can open up my console and see, hey, what happened? It looks like I'm missing my project. It's exactly why it's failing. So again, obviously not great for the demo and for successful runs, but very useful for me to now debug why this has stopped working. Maybe there's an issue with my repository that I have to dig into. Maybe it's some kind of issue with the slave machine that's trying to pick this up. It doesn't have access or permissions to access the files. So it's going to give me a really good idea just from my CI or CD tool what I need to do. All right. Great. So again, any questions, feel free to ping those. We'll take a minute here to go through and let those trickle in. Any comments, we'd love to hear. This is a session that I believe we're going to be running in the future as well. So let us know if there's anything you would have liked to see in more detail, anything that you feel like we could have explained a little bit better. Definitely just let us know either through the chat, comments, or through an email to us. And then finally, they wanted me here to mention some incentives. So now through the end of June, well, since recently in the end of June, we're running special pricing on new LoadUI purchases. This includes dedicated private training, understanding your use case, sitting down talking with you and then presenting a kind of a similar session, usually about an hour long, with exactly what you need to see and how to use the tool. Obviously open that up very kind of back and forth because it's a much smaller group and answering questions, that type of thing. So yeah, feel free to reach out to us here. We've got a really dedicated pool of account management specialists and people who are really trying to get you in the tool and using the tool to its fullest potential. It's not just me, running sessions like this. There's a dedicated group here at SmartBear that are really focused on customer success and get everybody up and running within our tooling. Great, so let's see what we've got with some of these questions here. Could I please repeat how server monitoring is able to gather CPU, memory, disk usage metrics? It's permissions-based system, so we need to make sure, and we've got some guidelines, some documentation on our website about this. We need to make sure that we have the appropriate permissions and that the port, essentially the correct kind of ports and services are open on the server for us to pull those metrics out. But for instance, on the the Windows monitor, it's connecting to the performance monitor system that lives within the tool or within the operating system and pulling the values out from there. It's the same thing that I would use for something like Rain Meter or something that's rendering out any kind of performance metrics, essentially just reading those from an internal process. And my understanding, it's very similar across, the Linux, Unix boxes. I'm not sure about the database, how we pull metrics from those, like MongoDB or something, but again, we've got some good documentation there. More than happy to share that with you. Another great question here. Do you have a utility to convert existing performance test scripts from other tools into LoadUI? This is one of my favorite ones when it does come up because we actually do have a pretty good answer for it. It's not really LoadUI that's going to do the job for us. It's actually in the projects tab. We have a feature here that's tucked away called API Discovery. And where is it? As I mentioned, tucked away. So this API Discovery feature is essentially going to stand up. Here we see an internal browser. We can stand this up as a proxy service. And what we could do is we could essentially say, okay, let's simulate one request or one sequence from our other performance testing tool, or let's take that test script and execute it once. And this proxy, the service, is going to record those transactions and pull them down into the platform. It's also going to recognize the sequence that they handled them in, or that they kind of came in at. So we'll be very easily able to take that sequence and then port it over into LoadUI. Now, it's not going to do all of the interesting things like data-driven loops, passing values, ensuring tokens are matched up with ones that were initially requested. That we'll still have to go in and kind of configure. But once we have the calls and the sequence, that should be a pretty painless process. Well, depending on how well the API is serving up data. But yeah, we do have a feature that helps with that. API discovery, REST discovery, whatever you want to call it. Tucked away in the projects tab there. I definitely encourage you to check that out. Another question here, how do you know the number of agents in a distributed load test? That is all visible through that distributed panel. Now, there's never going to be an agent that runs without me connecting to it. So if I have something in, let's say, a headless environment that's running, as an automated execution, it's not going to magically find all of the agents in the network and start to distribute load across those. I would have to manually set up those connections and then utilize them in the automated run. But definitely something we can do there. Just get some exposure to it here through this distribution tab. And I believe that we can pull these values into the reports as well. We can say how many agents were used. Another good question here, how do you know the agents are saturated and more need to be spinned up? We do get metrics similar to our performance monitors on the agent machines. So the tool will actually tell us, you might have seen it earlier, I reported my 90% CPU usage is kind of bordering on troublesome. Similar thing would happen with an agent. It would let us know if we have any kind of issue or if we're hitting kind of limit with what that agent machine is going to support. I very, very commonly see this used inside of a VM on an actual machine or a couple VMs running next to each other, where we have a very dedicated pool of resources available to that, and we can essentially allow the agent to make use of as much of those as we want because it is a dedicated resource. Same idea, if we had like a container, a Docker container with one of these agents in that's simulating our requests, we could potentially stand up a whole bunch of those next to one another and be very strict in what they are able to use from the host machine. What technique, another question here, what technique will we use to assure that we are hitting a service operation concurrently? So I'm not 100% sure on the kind of the direction of the question there. We would be able to see, I suppose, our transaction times. We'd be able to see when requests are run. We have an internal log that we can set up that would essentially let us know when we're simulating requests and when they're coming back. So potentially we could set this log up to collect that kind of data, generate it, and spit it out into some kind of report or table. That might be something that we'd want to explore in a little more detail. So I would encourage, check out the log, check out the different statistics that live under there that we might be able to use. But if there's any other leading questions or any other questions in that direction, feel free to reach out to us directly and we can get some more resources to you. Great. So I think we're here about 1:30. I thank everybody for joining the session today and for staying tuned. I hope, we've introduced the tool, and I think that we did a pretty good job staying in that 20-minute mark. So yeah, just want to thank everybody again for joining the session. Any other questions, just like I said before, feel free to reach out to us here at SmartBear. We have a ton of resources, be it through the community, through our support staff, through account management teams like me and sales engineering, who are really here to help you understand the tool, get used to the tool, find the best solution for what you're trying to do, and stand it up in your own environment. So yeah, just once again, thank you everybody for joining, and look forward to talking to you in the future. Thanks.